In this project, we will simulate the coronavirus spread in a car due to the cough of the driver. The present model is designed in 3 dimensions using Design Modeler software. Also, the meshing of the present project is done using ANSYS meshing software and the mesh type is unstructured.
By clicking on the subscribe button, you will be informed about the newest CFD training videos by Mr. CFD. Or if you are watching the training video, click on the Mr. CFD logo and subscribe.
Now, there are several assumptions taken into account for this project. First, the type of our solver is set to be pressure-based since we are dealing with incompressible flow. Second, we have selected the absolute format for velocity formulation. And third, we have selected transient time study since we are simulating a time progressing phenomenon. Also, we have enabled the gravity and its value is equal to minus 9.81 in the zero direction. In this window, under the injection type, select surface and then under the release from surface which appeared after selecting the surface as your injection type, select the mouth surface. Also under the particle type, select droplets since we are simulating the droplets of cough or sneeze. And under the material, you can see we have selected the water liquid. Also, we have a distribution of diameter of our particles which is selected to be Rosen-Ramler logarithmic. And since we have evaporation, we have enabled the evaporating species as water vapor. Also under the point properties tab, you can see the properties related to these injections. Now if you can remember, we said something about how to add a new material so that material can be used in the species model section. To add a material, you can simply right click on fluid, go over new. Now if you double click on the boundary conditions button in the appeared part under the wall boundaries, click on mouth and then click on edit button so that you can change the settings related to this boundary. Now if you double click on the controls button in the appeared part under the solution controls, you can see different values for current number and under relaxation factors. Now the current number is a factor showing that how fast we are progressing in our simulation process, and for the problems with high nonlinearities we should decrease this current number. Also under the relaxation factors are factors that are used for different reasons. The main reason is that they are used to damp the fluctuation and errors in each of these parameters and that they can have different values that are between 0 and 1. However, it is highly recommended that you do not change them since it may result in divergence. Now in this slide you can clearly see the temperature distribution over our generated plane after the driver coughs or sneezes. And now in this slide you can clearly see the velocity distribution over our generated plane. And finally in this slide you can clearly see the particle tracks in different time steps of our study. Finally, a summary of different settings and setup that we have used in our project is presented to you in the slide.
Obtain the mesh file and also the full training movie by purchasing this product.
Coronavirus is known as the biggest human challenge in the world today, and the high transmission rate of this disease is very problematic. Coughing or sneezing of a COVID-19 person without a mask can spread the virus of the corona in that space. One of the important recommendations of doctors regarding preventing the transmission of disease between people is to maintain social distance between people in small closed spaces. The interior of a passenger car can transmit the virus to its occupants. In this project, based on the CFD method and using ANSYS Fluent software, an attempt has been made to simulate the release of virus particles from the mouth of a corona carrier patient inside the interior of a car. The purpose of this study is to investigate the diffusion power of virus particle inside the car interior. For the present simulation, the discrete phase model is used, because this model allows us to study a mass of particles discretely or bit by bit in a continuous fluid space. Due to the choice of this model, the wet particles of the virus secreted from the patient's mouth are considered as a discrete phase, and the airflow inside the car is considered as a continuous phase. The physical models of discrete particles defined in this simulation include two-way turbulence coupling, meaning that the two-way interaction between continuous and discrete phase by activating the interaction mode with continuous phase. The present model is designed in 3 dimensions using Design Modeler software. The geometry of the model involves a car, but since the purpose of this work is to investigate the behavior of discrete virus particles inside the car, only the interior cabin space is defined as the computing area. A person is also designed as a car driver in car seat, which is defined as the source of cough virus. Hence, the surface of the patient's human mouth is differentiated by the mouth boundary condition because this surface is assumed as the reference level of discrete phase virus release in this model. Also, the meshing of the present project is done using ANSYS meshing software and the mesh type is unstructured, and the element number is equal to 290,403.
To benefit from Mr. CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.